Now, in the first question, they are asking what are the most important type of intermolecular forces, intermolecular attractive interaction in the following pairs. Okay, that means what type of interaction are there. Now, whatever the example that has been given, these 1 to 5, you can classify all of the molecules into two types. If you have any substance, you can classify it either into, it can be a polar molecule or a non-polar molecule. Okay, non-polar molecule. Now, when you have polar molecules, in that case, you can have either of the two interactions. You can either have a dipole-dipole, and if there is a bond between hydrogen with either fluorine, oxygen, or nitrogen, then in that case, you will be having hydrogen bonding. Okay, in that case, you will be having hydrogen bonding. In non-polar, you will have only one attractive interaction, and that will be which interaction? That will be the dispersion forces or London dispersion forces. Okay, so I hope these are old information. Yes or no? All of you have heard of all of these words and terminologies. Is that right? Yes or no? Please tell me.
Yes, sir.
Yes. Minashi, Maimuna, Khalil, all of you have heard this now?
Yes.
Yeah. Okay. And now also you know the relationship between the type of molecule and the intermolecular force of attraction. Correct? Yes or no? Is that right? When you have non-polar, then it will be London dispersion forces. If it is polar, then it will be either dipole-dipole. And if you have a bond between hydrogen, fluorine, and oxygen, it will be hydrogen bonding. All of you know of these things, right? Yes or no?
Yes.
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 Okay, fine, great. Now, for the first one, what do you think? What are these molecules? They are polar or non-polar? Hexane and octane. So what is hexane? You just have carbon and hydrogens like this, right? And octane will be just one carbon, two carbons more. So all of these are what? Polar or non-polar? Tell me, what do you think? Polar or non-polar? Yes, Seth, you want to say something?
I guess polar.
You're guessing polar. Anyone else? Hania, what do you think? Polar or non-polar?
Polar.
Polar. Samaira, what do you think? Polar or non-polar?
Sir, I forgot what does polar and non-polar mean.
Sorry, Samaira, can you repeat yourself? Could not hear you.
Sir, I forgot what does polar and non-polar mean.
You forgot about this. Acha, okay, fine. Let me ask a few more. Khalil, what do you think? Polar or non-polar?
Sir, polar.
Yes, polar. Okay, Maimuna, what do you think? Polar or non-polar?
Polar.
Polar. Okay, how do you identify, by the way? How do you say something is polar and something is non-polar? Tell me, acha. Is this polar or non-polar? Hydrogen, H2. H2 will be polar or non-polar? Tell me, Hishma, Maimuna, please turn your mic on and tell me now. Polar or non-polar? Khalil, bataiye. Khalil?
Sir, non-polar.
Non-polar. That means what did you check? How did you know that it is non-polar?
Symmetric.
Symmetric. Something else. One of the properties that
Negativity.
Electronegativity. Very good, sir. Very good. What do we check? We check the electronegativity difference. Electronegativity is also shown by the letter chi. It is big chi. So mole fraction is small chi, and electronegativity is written as like this. Okay, big chi, uppercase chi. Okay. So the difference in electronegativity is what? It is equal to 0 here for hydrogen and hydrogen. That is why these are non-polar. That means the electron is distributed equally. Electron is distributed equally. Achha, now you tell me for this one molecule. What about CH4, polar or non-polar? You must remember these things. Back in the head, whatever you are feeling, tell me that. Saf, you tell me, what do you think?
It's polar, sir.
It is polar. Okay. Khalil, what do you think?
The non-polar.
Non-polar. Maimuna, what do you think? Yes, Maimuna. Can you please repeat that? I could not hear it.
Non-polar.
It seems you're not having a good connection. Hishma, what do you think? Send your answer in chat. Non-polar. Hishma, Maimuna, send your answer in chat. Okay. Now, in this case, those who think it is polar due to the due to the difference in electronegativity, you must remember that the polarity, it depends on two things. One is the electronegativity, that is very true, and the another thing is the shape. Okay, it is the shape of the molecule. Now, as you can see, there will be all of these bonds are polar bonds. That is true. That means you will have a bond like this, which is, sorry, there will be a polarity like this. Okay, but there will be again a polarity like this towards carbon atom. Now, these two dipole moments, they will be cancelling each other out. Similarly, these two will be cancelling each other out. And that is why what you will see that there will be a dipole moment, net dipole moment, which will be of 0, because all of the dipole moment, they cancel each other out. Now, one thing you should remember very carefully, one line that I am writing. See, there are two things if you remember electronic geometry. When the electronic geometry and the shape of the atom are same, for methane, the electronic geometry is tetrahedral and the shape is also tetrahedral. When the electronic geometry and shape are equal and they have same surrounding atoms. And in this case also, what do we have? Hydrogens, 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 hydrogens. All of the atoms are same. So when you have electronic geometry which is equal to shape, and the surrounding atoms are what? They are same. It means that the molecule will be non-polar. Okay, so this is an observation that you can remember. When the electronic geometry is equal to shape and the surrounding atoms are same, then the molecules are non-polar. And all of the alkanes, whatever you have, such as methane, ethane, propane, pentane, hexane, octane, all of these alkanes, they will be what? Non-polar. Okay, so they all will be non-polar. And since they are non-polar, what will be the interactive interaction? The attractive interaction will be London forces or London dispersion forces. I'm writing London forces. Okay. Now, what do you think about I2 and CCl4? Polar or non-polar? Now, I want answer from everyone. I hope it is clear with everyone now. I2 and CCl4? Yes, Khalil correct, Salman correct. Non-polar. All of you agree? Yes or no? Please tell me. Hishma, Maimuna, Nawal, Samaira, आपको समझ में आया?
Yes, Ali.
Okay. याद आ गया? ठीक है. So all of these will be non-polar. I2 because it is having no electronegativity difference. And in CCl4 we have electronic geometry which is equal to shape and the surrounding atoms are same, and it is giving me non-polar. So this will be also non-polar, and it will give me London forces. Okay. But the case of NaCl4 and water is a bit, you have to remember for this case. Okay, what you have to remember that NaClO4, it will dissociate into Na plus and ClO4 negative, right? So we have ions here. Okay, we have ions here, and water is going to be having a dipole. Okay, water is going to have a dipole. Now, in this case, for a particular case, when you have ion and dipole, so the interaction will be between ion dipole. So this will be ion dipole interaction. Now, methanol and acetone. So methanol is also what? Methanol is having CH3OH, and acetone is C double bond O, CH3 and CH3. Now, in this case, both of these are what? Dipole. So here you will be having, these are polar molecules. and they will be having dipole interaction. Yeah, correct. Similarly, acetonitrile and acetone, these are again what? These are again polar molecules, and they will be having same dipole interaction. Is this clear? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay. Now, why are we learning about the intermolecular attractive interactions in the chapter solution? Because solubility depends on these interactions. Okay, solubility depends on these interaction. Now, solubility has a very good thumb rule that you can remember. Like dissolves like. Okay, like dissolves like. That means polar will dissolve polar, and non-polar dissolves non-polar. Okay, so अच्छा एक बात बताइए, when you have Na plus and Cl negative, is this polar? Yes or no? Tell me, what do you think? Is this polar or non-polar? When you have Na plus Cl negative, what do you think, guys? Tell me, polar or non-polar? Not sure? Yes. Tell me, guys. Okay, Khalil says polar.
Polar, sir.
Polar, na? Obviously, it is the extreme case of polar. It is the extreme case of polar. If you remember, HCl will be what? Polar, because it is having delta positive and delta negative here. And this is the extreme case when you have a complete positive charge and a complete negative charge. So this is also what? Polar. And that is why in water we can easily dissolve NaCl, right? In water we can easily dissolve NaCl. So polar will dissolve polar and non-polar will dissolve non-polar. Now, if I look at the next question here, based on based on solute solvent interactions, arrange the following in order of increasing solubility in N-octane. So what is the solvent here? As you can see, what they are saying, in order of increasing solubility in N-octane. That means our solvent is N-octane. And N-octane is what? Polar or non-polar? Tell me. N-octane will be
Non-polar.
non-polar. We have just saw non-polar. Okay, now it is non-polar. And what are the solutes that we are having? Case cyclohexane is there. So let me, okay, I think I can bring this here. Okay, so what do we have? We have here cyclohexane. And what we will do, we will also write here, it is going to be non-polar, right? Then we have KCl. Now we know KCl will dissociate into K plus and Cl negative. So we'll write very polar. The extreme case of polarity. We have a complete positive and complete negative, very polar. Then we have CH3OH. This will be polar. And we will have CH3CN. This will be also polar. Now between these two, what do you think which is more polar? CH3OH or CH3CN?
CH3Cl.
CH3CN will be more polar, you think?
CH3O.
Okay, which is more electronegative, oxygen or nitrogen? Tell me, which is more electronegative, oxygen or nitrogen? Oh, you don't remember the electronegativity series? ये याद करके रखिए, it's very helpful. Eleventh class wale, do you guys remember how to remember this? No. Huh? Samaira, Salman, phone, call, Bihari, इश्क, प्यार है. Can you guys remember this now? Khalil, याद नहीं आया, भूल गए सब. अच्छा, Khalil, you may not remember this because you joined late, I think, right? Phone call Bihari, इश्क प्यार है ना? Please write this down. It's very helpful. Very helpful. Electronegativity series. Okay, this is the series for electronegativity. So now, as you can see, that which is more polar. This is more polar. This is less polar. Now, if I compare, then 1, 2, 3, 4. Now we have a solvent which is non-polar. Then it will dissolve non-polar very easily. Yes or no? Please tell me. Tell me, yes or no?
Yes, sir.
So tell me first of all, which will be least dissolved, which will be least soluble. Least soluble कौन सा होगा? Least soluble will be
KCl.
KCl. That means second one will be least soluble. After that,
CH3OH.
CH3OH. Very good. After that,
CH3CN.
CH3CN, and then we have the non-polar cyclohexane. Is this clear with everyone? Yes or no? Samaira, Saif, Salman, Nawal. Nawal, how are you? आपकी आवाज ही नहीं आ रही है.
Yes, sir.
Understood?
Yes, sir.
Okay. Very good. Chaliye, please write all of this down. If I need to scroll up, please let me know. Should I scroll up or you have written the above part? Okay, it seems you have written the above part. Please write this down then. Let me know when you're done. Acha. One more thing, Saif, what was the last thing we studied in your class, solutions mein?
We did the colligative properties. Last thing was depression freezing point.
Okay, so there are two things which are remaining that will be done in one class. So हमको ना आपके साथ एक extra class लेना पड़ेगा. Are you free on Saturday, Sunday? Yes,
No,
Saif?
sir.
No? Like,
On Saturday, Sunday, I have two classes. From
Oh,
4
Saturday,
o'clock
Sunday.
to 6. From 4 o'clock to 8 o'clock, I have class.
oh, from 4 to 8 you have classes on Saturday, Sunday. Okay. Fine. So there are two topics, osmotic pressure and abnormal molar mass. Okay, so I have to complete these for you. Today we will be starting. Acha, in your school, Haloalkane and Haloarene has been started, right, Saif?
No, sir.
No? Then what did you start? Electrochemistry, kya?
Electrochemistry just finished. We have started D and F out this
Oh.
DNF group.
अच्छा. Okay, fine. So electrochemistry, अच्छा, आपका भी electrochemistry है. Okay. So एक काम कीजिए, you attend today's lecture है ना? Just get introduced with haloalkane, haloarene. I will be not doing any major stuff today. Then I am sorry, I have to again shift you to some other batch in which electrochemistry will be going on. Okay, Saif?
Okay, sir.
It will be on Monday or Wednesday, or it will be the same time or Tuesday, Thursday. No, Monday, Wednesday most probably. Monday, Wednesday. Timing will be. When do you start? From 6, na? From 6 p.m. You're
On
free
Monday,
that time?
Wednesday, I have physics.
6 p.m. say?
6 p.m. to 8.
Okay. Okay. So everyone is done now. So let me add the section for haloalkane, haloarene. Today is Tuesday. Okay. So before starting, let me write a question. And don't worry if you don't know the answer, okay? Please write the question. Identify the following as aliphatic, aromatic, saturated, unsaturated, primary, secondary, and tertiary. Okay. Don't worry if you don't know. And if you know also, then also don't worry. They are sorry. Please write this down. Yeah. So tell me. All of you wrote the question, yes or no? Please tell me.
Yes.
Yes, Samaira, Salman, Nawal, Saif, Minashi, Mazia.
Yes, sir.
Okay, fine. Now the first thing I want to ask is, I have written a few terms here: aliphatic, aromatic, saturated, unsaturated, primary, secondary, tertiary. Please raise your hand if you don't know the meaning of any one of them. Please raise your hand if you don't know the meaning of any one of them. Okay, 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 okay. Oh, oh, oh. Okay, 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 okay. Fine, fine, fine. ठीक है. So most of you don't know the meaning of any one of them. How many of you? Please keep your hand raised if you don't know the meaning of aliphatic. Please keep your hand raised if you don't know the meaning of aliphatic. Okay, fine. ठीक है. Please raise your hand if you don't know the meaning of aromatic. Please keep your hand raised if you don't know the meaning of aromatic. Aromatic, aromatic, aromatic. Okay, free. Okay, fine. Very few. Very few. Minashi, I think you know the meaning of aromatic, right, Minashi? But you're not sure? Minashi? Tell me. Aromatic, as of now, what we will say, anything that is benzene like, that is having benzene, it will be aromatic as of now. We all know that there is a big definition for aromatic molecules in which you should have planar structure, then there should be pi bonds, and the number of pi electrons should be equal to 4n plus 2. So all of these rules stands, but as of now, for the purpose of identification, what we are going to do, we are going to say anything that is benzene, it is going to be aromatic. Okay. Now, those of you who don't know aliphatic, anything other than aromatic is aliphatic. Is that clear? Yes or no? Please tell me. Now, all
Yes,
of you
sir.
know what is aliphatic,
Yes.
right? Alkane, alkene, alkyne. All of these things, they will be what? They will be what? They will be aliphatic. Is this clear? Yes or no? Please tell me.
Yes, sir. Clear.
Clear. Okay, fine. Great. Now, saturated, raise your hand if you don't know what is saturated. Raise your hand if you don't know what is saturated. Okay. So saturated hydrocarbons. See. Saturated hydrocarbons and unsaturated hydrocarbons. Listen here. If you have one carbon, then the maximum number of hydrogens that you can add is 4. If you have 2 carbons, then the maximum number of hydrogen that can be present in the molecule is equal to 6. Is that right? Yes or no? Please tell me. Nawal
Yes,
and
yes.
Matthew. Nawal
Yes.
and Matthew. Nawal.
Yes, sir.
Yes, sir. It's clear.
Very good. ठीक है. नवाल से पूछ रहे थे. Okay. If you have 3 carbons, now tell me, then what will be the maximum number of hydrogens that can be present?
8.
How many, Nawal?
8.
8. Very good. Now, can I add more hydrogens in either of these molecules? Tell me. Is there any
No.
chance by doing any type of reaction, can we add any other hydrogens? No, right?
No, it can't.
No.
It can't.
That means when you can't add more hydrogens, that means it is saturated. Clear? Hai? Is that right? Yes or no, Nawal and
Okay, sir.
Matthew?
Clear.
Now,
Yeah, yeah.
clear? Okay, fine. Now, if you have something like C double bond C, and there are 2 hydrogens and 2 hydrogens on each of the carbons. Now, this is having 2 carbons, but it is having only 4 hydrogens. But the maximum number of hydrogen that you can have when there are 2 carbons, it is equal to 6. That means by doing some kind of reaction, I can add more hydrogens. Is that right? Yes or no? Please tell me.
Yes.
Yes, sir.
Right? So these are the cases which are saturated hydrocarbons in which you can add more hydrogen. Sorry, saturated in which you cannot add more hydrogens, and these are unsaturated in which you can add more hydrogens by doing some kind of reaction. So now I hope everyone is clear with unsaturated and saturated. Yes or no, Matthew
Yes, sir.
and Nawal?
So can I
Okay.
say like saturated hydrocarbons don't have a double bond or triple bond?
Yeah, they do. They will never have a double bond or a triple bond. Okay.
Okay.
Now, so saturated and unsaturated is clear. Primary. Anyone who has difficulty in primary? SAF. Okay, primary, secondary. Primary, secondary, tertiary. Is there anyone who has problem? Okay, fine. Okay. Now, what do you think? Where should be our focus on this molecule? Tell me. On which carbon should we focus? 1, 2, 3, or 4? क्या
Three,
लगता
I
है? देख
guess.
के. Okay. I hope everyone will agree, right? The third carbon is something that we should focus on. Okay.
Yes.
That means the third carbon is having a fluorine group which is different than hydrogen and carbon. Now, when this carbon, the carbon which we are focusing on, and this definition will change. Now we are having fluorine. There may be some other group. There may be some charges. Now this carbon, it is connected to 2 other carbon, and that is why it will be known as secondary. So, okay. Now, for example, if you have something like this, CH3, CH2, positive. So in this case, tell me, which carbon should we focus on?
Second one.
Second one, right? Now this will be having, it is connected to only how many carbons? It is connected to only 1 carbon, and that is why it will be primary. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, one thing about organic chemistry that I want to tell you guys is that it is very much rule based, I would say, and not law based. Now, when you have law, for example, when you have Henry's law and you have Rawls law, you have laws for osmotic pressure, you have laws for relative lowering of vapor pressure. In these cases, what is there? You will be getting deterministic answer. Deterministic answer, that means 7.8, 7.18. This will be one answer. It will be not here and there from, it cannot be 10. It cannot be 10. Okay. But in organic chemistry, you have to go with rules. For example, the rule is here what? For primary, secondary, and tertiary, the carbon that we are focusing on, right? And this is a rule, the carbon that we are focusing on, and it will be changing with one example and the other example. Okay. So slowly and slowly, organic chemistry, you can never grasp in one class. Slowly and slowly, you should be identifying things which are important. And I will be telling you explicitly which are things important and how you have to think in the ways of organic chemistry. Okay. So now can I start with this one? Now, first of all, tell me the first one, aliphatic, aromatic. Is this aliphatic? First one is aliphatic. Yes or no? Please tell me. Is the first one aliphatic?
Yes, sir.
Yes or no?
Yes.
Please keep your mic on. Nawal, Salman, Saif, keep your mic on. Keep your mic on. I know one. I want yes or no. Okay. First one is aliphatic. Is it aromatic?
No, sir.
No,
No.
sir.
First one is not aromatic. Is it saturated?
Yes.
Is it saturated?
Yes.
Very good. It is saturated. Who is saying no? It is saturated. No? Only single bonds.
Yeah.
Okay. Only single bonds. Unsaturated?
No.
No.
No, it is not unsaturated. Primary?
Yes.
Is it primary?
Yes, sir.
No.
No. Which is the carbon? We have to focus on this carbon, right? And this carbon is connected to how many carbons? 2 carbons. That is why it will be secondary. Is that right? Yes or no? Please tell me.
Yes, sir.
Yes.
Right? It is, and if it is secondary, it will not be tertiary. Okay. For the second one, aliphatic. Is it aliphatic?
No.
No.
No. Is it
No.
aromatic? Is it aromatic?
Yes.
Yeah. Is it saturated?
No.
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 Is it unsaturated?
Yes.
Yes.
Okay. Is it? No, it will not be primary, secondary, or tertiary because we don't have any carbon which we can focus on, right?
Yes, sir.
Yes.
Right. All of the carbons are same here. Okay. For the third one, aliphatic.
Yes.
Yeah. Because yeah, it is aliphatic because it is not aromatic. Okay. If it is not aromatic, it will be aliphatic. Okay, fine. If it is aliphatic, it will not be aromatic. Saturated?
No.
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 No, it is unsaturated. Very good. Okay, now again, all of these carbons you cannot rather focus on, and we'll not focus on any one of the carbons as of now. So we cannot say it is primary, secondary, or tertiary. Okay. Now moving to the fourth one. Fourth one is important. It is a bit tricky also. Tell me. Fourth one will be aliphatic or aromatic?
Aliphatic.
Aliphatic or
Aliphatic.
aliphatic? Very good. Saturated or unsaturated?
Saturated.
Saturated.
Saturated. Very good. Saturated. Not only primary, secondary, or tertiary.
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 देखिए यही. This is the carbon where we should focus on. Yes or no? देखिए this is the carbon where we should focus. Correct?
Yeah.
Right? Yes or no?
Yes, sir.
Yes, na. And how many? It is connected to how many carbons directly?
One.
Only one carbon, right? So it may seem like it is tertiary. That is why it will be primary. So this will be fourth is primary. Okay. Fifth one, aliphatic or aromatic? Okay, wait a second. All of you got this now. How fourth is primary? Yes or no? Please tell me now.
Yes.
Samaira,
Yes, sir.
Nawal.
Yes, sir.
Yes, now. Okay, very good. Now, fifth one is what? Aliphatic or aromatic?
Aliphatic.
Oh, who said aromatic? Benzene ring nahi hai. There is no ring here. It is an alkene. It's like aliphatic. Very good. Okay. Fifth one. It will be not aromatic. Saturated or unsaturated?
Saturated.
Saturated.
Saturated. ठीक है. Primary, secondary, or tertiary? Primary, secondary, or tertiary?
Secondary.
Secondary.
Secondary. Very good. Very good. So secondary. Okay. Now the sixth one, aliphatic or aromatic?
Aromatic.
Aromatic. Very good. Saturated or unsaturated?
Unsaturated.
Saturated.
Saturated. ठीक है. Primary, secondary, or tertiary, you don't bother here, okay? Even though it is secondary, but because it is aromatic, now we don't consider. Now we have to play a game where we have to choose whether we should be focusing on primary, secondary, tertiary, or the aromatic nature. Now we can see that it is evidently very much aromatic. So the aromatic nature will be more dominant here than the primary, secondary, and tertiary. Whatever properties whatever properties are there due to primary, secondary, and tertiary, it will not be very dominant. Rather, the aromatic part will be very dominant. Okay, so even though it is secondary, you can say, but still we don't consider it secondary, and reactions also we don't consider it secondary. Okay, now this is what I am saying, that it is probabilistic. Organic chemistry is not deterministic, it is probabilistic. That means it is aromatic also. It is secondary also. Now you have to choose which one of it is dominant. Now here the aromatic nature is dominant. That is why we'll be more focusing towards the aromatic nature. Okay. Now the seventh one में बताइए, aliphatic या aromatic? Aliphatic.
Aliphatic.
Very good. Now, saturated or unsaturated?
Unsaturated.
Unsaturated. Very good. Okay. Now, primary, secondary, and tertiary, we don't have to consider because it is unsaturated here. We don't have any carbon to focus on. Okay, fine. So, I think now you will be more comfortable with these terminologies. Yes or no? Please tell me.
Yes, sir.
Yes.
Okay, very good. Okay. Now, write the heading haloalkenes and haloarene. Haloalkenes and haloarene. Now, what are haloalkanes and what are haloarene? First of all, so whenever you have a aliphatic carbon, aliphatic hydrocarbon, okay, and you exchange the hydrogen with any of the halogen atoms. You exchange hydrogen with any of the halogen atom. What are these halogen atoms? It can be fluorine, chlorine, bromine, or iodine. So when you remove, now this is not a reaction. We are just saying how can you can identify this. Okay, so you will be getting haloalkenes, and these are also known as alkyl halides. Okay, alkyl halide. For example, in methane you have 4 hydrogens. Okay, you can write with me. There is no much concepts going on here. You can write with me. Okay, and you exchange 1 hydrogen with chlorine. Okay, so what you will be getting? Hydrogen, carbon, hydrogen, hydrogen, and there will be 1 chlorine. Now this is a chloroalkane. Or we can write this as chloromethane. The common name for this will be methyl chloride. Methyl chloride. Similarly, You can also have CH3, CH2, CH3. Now here also we can exchange any one of the hydrogen with any one of the halogens. Let us take Br here. Now I am exchanging this middle one. So you will be having CH3, there will be CH, and the Br will be in the second carbon followed by a CH3. Now in this case, what will be the name? Now since the bromine is attached on the second carbon, it will be 2-bromo propane. Okay, 2-bromo-propane. We will come to the IUPAC nomenclature extensively. Just now we are writing the names here. Okay, is this clear? Yes or no? Please tell me, guys.
Yes, sir. Clear.
Everything is clear till here, right? Now, when you will get haloarenes? Whenever you have aromatic hydrocarbons, and you exchange one hydrogen with halogen, you get haloarene. We also call this as aryl halide. Okay, aryl halide. For example, our benzene ring, it has a formula what? C6H6. So all of the carbon atom, it has one hydrogen attached to it. Okay, you just remove one hydrogen, and in place of that, you will add a bromine here. So you will be getting Br here, and all of the other hydrogens, they are intact. So this will be what? This will be bromo benzene. And also, for example, you have the CH3 group here. This is also a aromatic hydrocarbon, and you exchange one of the hydrogen that is in the benzene ring with Br. In this case, you will be getting the CH3 will be intact, and there will be Br here. Okay, so these are the examples for aromatic hydrocarbons, haloarenes. Done? Can I move on? Yes or no? Please tell me. Is everyone done?
Yes,
Still
sir.
writing.
Last one.
Done?
1 minute, sir.
Okay. Right. हो गया? Not done.
Done, sir.
Done. Okay. Now, right, classification of haloalkane and haloarene. Okay. The first classification, it is on the basis of number of halogen atoms. That means whether you have one halogen, two halogen, or three halogen atoms. So please write on the basis of number of halogen atoms. Okay. So it is categorized into three parts. When you have only one halogen atom. You have two halogen atoms. Excuse me. When you have three halogen atoms. So when you have one halogen atom, the haloalkanes, they are known as monohaloalkane. Haloarenes are known as mono haloarene. Okay. Let me just turn my mic off, and I hope you can just copy it down while I'm writing. Okay. Okay. So I hope you have written all of the classification, and you can also write the question. Is everyone done writing the questions? Yes or no? Please tell me.
No, sir. 1 minute.
Okay. Saf, समझ में आ रहा है?
Yes, sir.
Okay. Okay, everyone done with the questions? Yes or no? Done, na?
Yes, sir.
Okay, chali. Tell me for the first one. First of all, tell me.
Monohaloarene.
First one is mono.
Haloarene.
Why haloarene? There's a
It's an
haloalkane or
aromatic. It's an aromatic group, right?
Why aromatic group?
Oh yeah, no,
Aromatic.
it's a, not a.
No,
Yeah,
na?
yeah, it's a. Yeah, yeah. I just
Okay, what
realized
about
it.
others? Nawal. Just realize. Yes, Nawal, Minashi, Masia, Maimuna, Khalil. All of you tell me. Mono, halo,
Alkane.
alkene. Very good. Okay, for the next one, tell me. Mono, di, or tri? First of all, tell me that. Mono, di, or tri?
Di.
I.
Di. Okay. Haloalkane, haloarene.
Haloarene.
Okay. For the third one. Mono, di, or tri?
Try.
हाँ एक ही दो की आवाज आ रही है. What happened to others? Please keep turn your mic on. Samaira, Nawal, Saif, all of you tell me. Mono, di, or tri?
Try.
Try.
Tri. Haloalkane or arene?
Haloalkane.
Alkane.
Alkane.
Very good. Haloalkane. Confuse नहीं होना है. Fourth one, mono, di or tri?
Die.
Die.
Di. Haloalkane, haloarene.
Haloalkane.
Alkane.
Fifth one, mono, di or tri?
Try.
Tri.
Tri. Haloalkane or arene?
Alkane.
Haloalkane.
Alkane. Sixth one, mono, di or tri?
Die.
Di.
Di. Haloalkane, haloarene.
Arene.
Haloarene. Very good. Okay. Now, the monohaloalkenes that we have, they are classified into two major parts. Okay, please write. Mono haloalkane. Okay, what do we have? We have monohaloalkenes. The monohaloalkenes which are attached, that means the halogen atom which is attached to sp3 hybridized carbon atom. And there are others which are attached with sp2 hybridized carbon atom. Is this clear? Yes or no? Please tell me. There
Yes,
can be
sir.
two types. Okay, now raise your hand if you don't know what is sp2 and sp3. Raise your hand if you can't identify sp2 and sp3 carbon atoms. Okay, all of you can identify, right? I think all of you can identify. Okay, फिर भी, but still what I am doing. Okay, see, if a carbon has one double bond, it is going to be sp2. If it has two double bond, it is going to be sp. If it has one triple bond, then also it is going to be sp. And if it has no double or triple bond, then it is going to be sp3. Clear है सबको? Yes or no? Please tell me.
Yes, sir.
Yes.
यहाँ पे if a carbon has कर दीजिए. If a carbon has, okay, if a carbon has one double bond sp2, two double bond sp, one triple bond sp, one no double or triple bonds sp3. Now the sp3, the halogen atom connected to the carbon which is having sp3 hybridized carbon, the first type for them is alkyl halides. Okay, it has a commonly written as Rx. It is commonly written as Rx. Now this alkyl halide, it will have some other categories. The number one category is primary alkyl halide, right? So I hope all of you can identify what are primary alkyl halides. The carbon atom of CX bond will be directly connected to one carbon atom. And I'm writing some examples here. Look at the examples and you will understand. CH3, CH2, Cl. This carbon atom, it is attached with one carbon atom. That is why it is primary, right? Another example you can write CH3C, CH2Br. Okay. Now these type of examples, don't get confused. Here also, this carbon atom which is connected to Br, it is connected to only one carbon atom. Is that right? Yes or no? Please tell me any doubt in here. Primary haloalkane, primary alkyl halides. No problem. Write the B part. Secondary alkyl halides. In this, the carbon atom which is connected to halogen atom is further connected to how many carbons? Two carbon atoms, right? So in this chapter, our focus will be on the carbon which is containing the halogen atom. So you have CH3 bonded to CH. This carbon has another CH3 bond, and then it is bonded to, let us say, Br. Okay, now this you can see. This is the carbon atom which is connected to Br, and it is connected to furthermore two carbon atoms. That is why it is secondary alkyl halide. Right, the third one, tertiary alkyl halide. I hope all of you are clear with this primary, secondary, and tertiary. I don't think you will have much problem here. Still, I'm writing some examples. Keep writing with me.
Sir, can you go up little?
Okay, you are not writing. Write with me.
Yes, sir, just the example.
CH3, 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 and this is further connected to, let us say, Br. Okay, so this is the carbon connected to Br, halogen atom, further connected to 3 other carbons. That is why it is tertiary. It is what? Tertiary. Then all of you, yes or no, please tell me. Primary,
Yes,
secondary, and
sir.
tertiary. Okay, fine. Now, write the second one. The second classification in this case, where it is connected to sp3 hybridized, it is allylic alkyl halide. This is very important. Okay, you need to recognize this allylic alkyl halide. In this, what happens? Halogen is connected to sp3 carbon, which is further connected to carbon-carbon double bond. That means further connected to sp2 carbon. Okay. So for example, first of all, halogen atom X connected to a sp3 carbon, that means CH2, right? Which is further connected to carbon double bond carbon, that is carbon double bond carbon, like this. Or else you can have example, let us write Br connected to sp3 carbon CH2, which is further connected to double bond carbon. This can also be one example. All of you understood this? Yes or no? Please tell me. Allylic alkyl halide. Clear hai? Yes or no? Please tell me.
Can you
Yes.
So
explain again?
allylic case, halogen atom. Can you please read this? Read it out loud now.
Which one, sir?
This line.
Halogen connected to sp3 carbon, which is
हाँ wait
further
wait 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 अरे अरे भाई 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 आराम से ऐसे पढ़ेगा तो समझ में कैसे आएगा. See, you read there. See, halogen. Yes or no? You look here. Halogen connected to sp3 carbon, further connected to carbon double bond carbon. Yes or no?
Yes, sir.
Again, halogen connected to sp3 carbon, further connected to carbon double bond carbon. Okay.
Okay.
Chaliye. So what is the name for these type of alkyl halide? These are called allylic alkyl halide. These are known as allylic alkyl halide. Then right next, the next one is also very important. Benzylic alkyl halide or benzylic halide. In this case, please write halogen connected to sp3 carbon, which is further connected to benzene ring. Okay, which is further connected to benzene ring. Now for this, the example, again, similar example, okay? Halogen connected to sp3 carbon. sp3 carbon will be CH2. This CH2 is further connected to benzene ring. Easy, yes or no? Please tell me. Halogen connected to sp3 carbon, which is further connected to benzene ring. So this group here, it is known as the benzyl group. Okay. Furthermore, you can have, let us say, for example, if Br connected to CH2, which is further connected to a benzene ring. Can I move forward? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay. Now let us look at the case for sp2, the halogen atom connected to carbon, which is
Sir, could you show the benzylic halide again?
हाँ लिखिए, नहीं खुद से लिखिए, खुद से लिख लेंगे खालिद। खालिद
Yes,
डेफिनेशन
sir.
लिखा आपने? डेफिनेशन लिख लिया है?
No, sir. I was noting it down.
डेफिनेशन नहीं लिखा, एग्जांपल खुद से लिखिएगा लेकिन, ठीक है? हम सिर्फ डेफिनेशन दिखाएंगे
Okay.
आपको, ठीक है? लिखिए।
Okay, done.
Done. अब देखिए, in the next class I will ask these definitions. Okay, what is allylic, what is benzylic? Please remember these two at least, allylic, benzylic, and then for the next these two, sp2. And though you have two cases in sp2. Number one is vinylic halide. What is vinylic halide? Halogen directly connected to carbon double bond carbon. That means you have carbon double bond carbon, CH2 double bond CH. Now this is directly connected to what? A halogen atom. Let us say X. Okay, so this will be an example. Now the important point to look here is, what is the most important point here? In the vinylic halide, there are lone pairs like this. Now this lone pair can take part in resonance, and you will be getting two resonating structures like this. And both of these will give you a resonance hybrid, which will be CH2, CH and X. And this bond, the CX bond, is what? Having partial double bond character. And that is why it is tough to break. Okay, so write a note here. CX bond has partial double bond character, hence tough to break. Okay. Okay. Now raise your hand if you did not understand ये क्या partial double bond क्या होता है, ये resonance क्या होता है? Please raise your hand if you did not understand this point of partial double bond and resonance. All of you understood? New students? Okay, everyone understood. Okay, fine. Chalo, very good then. Write this down. Vinylic halide, halogen directly connected to C. This is why these type of definitions are important. Vinylic halide. Whenever you see vinylic halide, that means you will say that, okay, fine, wait. We will not break the carbon and halogen bond. What we will say? We will not break the carbon and halogen bond, whatever type of reaction is happening. And even if we have to break the carbon and halogen bond, we have to give some heat in that. Okay. So generally, vinylic halide, they will not show your common reactions that alkyl halide or haloalkanes they show. Okay, so vinylic halide will not show these type of reactions, the common reactions that is shown by haloalkanes. Can I move on? Yes or no? Please tell me. लिख लिया सबने?
No, sir.
Yes.
नहीं. Okay, those who have written, they can write the second one. That is aryl halide. Now in aryl halide, we all know halogen is directly connected. Halogen is directly connected to benzene ring. Okay, halogen is directly connected to benzene ring. इसमें examples में लिख लीजिए आप. Br. So all of these will be examples for what? Aryl halide. Here also you can see that there will be resonance. Okay, so here also you will note CX bond in aryl halide has partial double bond character. नवाल समझ में आ रहा है?
Yes, sir.
Very good. Due to resonance. So write this down. Then we will move to nomenclature now. Okay.
Done, sir.
Is anyone still writing? Is anyone still writing? No, no one is writing. Okay, fine. We'll start nomenclature. And I want to show something to the new students. Hai na? Those old students, they know what is the how to write the names my way, right? Nomenclature. Now, we have this molecule. It is given in NCERT as one of the examples. And I will also give you the name for this, okay? I will show you what NCERT has written the name, and then we will observe the name. We will observe the name. Wait a second. Now, the name here, this E, it represents that there is no functional group. That means it is talking about the functional group, whether what functional group is present or whether no functional group is present. Okay, so E here, it is talking about functional group. Okay, then we have En. Those who are students which are new, they can also understand that En, it is telling me about the double bond. And if there was double bond and or triple bond, then it will be Yn. If there was no double or no triple bond, then it will be An, right? Yes or no?
Yes,
All of you
sir.
can, yeah. Okay. I hope everyone knows En will be for double bond. That means it is telling me about the unsaturation. Yes or no? कि double bond है, triple bond है या single bond है? Is that right? Yes or no? Please tell me. All of you agree till here?
Yes, sir.
Then we have this pent. What is this pent telling me about? Pent is telling me about the main chain, the parent chain. Yes or no?
Yes,
Correct.
sir.
Yes.
Then we have one more. What color should I pick now? We have done with blue. Okay. Yellow. Then we have this bromo. What is this bromo telling me about? Bromo is telling me about the bromo is a
Halogen.
substituent here. No, substituent, right? Correct.
Okay, sir.
It is a substituent. It can be methyl also, na? Methyl आपका कहीं इधर बाद में नहीं आता है ना? You will never have methyl, or you will never have chloro in the parent case or the unsaturation, right? So bromo, it is what? It is a substituent. Okay. Now what we can do? We can say that each and every name, each and every IUPAC name, it has 4 things in it. It has substituent. It also has parent. Then it also has unsaturation. And what else it has? It has a functional group. Okay. It has a functional group. Okay. Now, for the functional group, you have to remember the priority order. Now, I will be writing here some functional group. I hope that you know what are those functional group and what are those Suffix. Please tell me, all of you know what is oic acid? Yes or no? Please tell me. Oic acid.
Yes, sir.
Raise your hand if you don't know what is oic acid. If you have never heard of oic acid. All of you have okay. Saf, oic acid नहीं पता? What do you think it may be? Tell me which functional group कौन सा functional group हो सकता है ये?
I guess COH.
Very good. So you know na carboxylic acid, right? COOH. Very good. Okay. Now after this, I should be writing sulfonic acid here, but sulfonic acid is rarely used. That is why I will write the next common case, that is of O8. Okay. O8. O8 is used when you have COOR, that is a ester group. Ester group, then we will be naming this in which chapter? Alcohol, phenols, and ether. Very widely, we'll be naming things which are esters. After that, I'm skipping oil halide, which is never used much, and I'm writing amide. So amide is the case where you have CONH2. Okay. Then we have nitrile. Nitrile is the CN. If the CN is present, then you will write nitrile. And after that, AL. AL will be for aldehydes, that is CHO. And even if you don't remember now, you must be, oh, ha, ye to suna hua hai. Oh, ha. If you are getting this type of feeling, then also it is fine. If you have on, then it is what? Ketone. C double bond O. There is one carbon here, there's another carbon here, like this. Then after that, OL. This will be for alcohol, the OH group. And at last, we have amine, which will be NH2. Okay. Now, the last thing is very important. If none of these is present, if you don't have any of these, then you will be writing for the functional group. In the place of functional group, you will be writing just E. Is this clear? Yes or no? Please tell me. Clear as sabko? Yes or no? Nawal.
Yes,
And who
yes.
is new here? Saf and Nawal are new. Na? Everyone else is old student only, right? Hania is new. Hania, आपने 11th नहीं किया ना हमारे साथ?
No, sir.
There is a song for that, you know. What is that song? Have you heard of that song? Isme tera ghata, right? Okay. For unsaturation, what do we have? For unsaturation, if you have double bond, then we will be using the word En. If you have a triple bond, then we will be using the word Yn. And if you neither have, if you don't have double and don't have triple bond, that means you only have single bonds and will be using An. But if you have both double bond and triple bond, then we will be using words like E9. Okay, now these cases, this will be explained with examples and you will understand them. Okay, don't worry about this now. Just write it here. Now for parent, I hope everyone knows what are the conventions for parent. If you have one carbon, then it is meth. If you have two carbons, then it is eth. If you have three carbons, it is prop. Then what? Bute. Then pent, hex, hep. Now, if you have a ring, then you will add the word cyclo. Add cyclo. If ring is present. Now, whatever I am writing till here, all of these cases are only for alkyl halides. These are not for benzene containing molecules. For benzene containing molecules, I will be talking in the next class. Okay. Now, substituent, you can classify substituent into three major categories. You can say that, not three, I can say there are four rather. You can say that either the NO2 will be present. If NO2 is present, then we write it as nitro. And if there is OR present, then we write it as alkoxy. And if there is a halogen present, then we write it as halo. So for halo, we start with fluoro, chloro, bromo, iodo. And there can be some alkyl group present, such as methyl, ethyl as a substituent, right? Alkyl. Okay, so please write this down. This is the crux of all IUPAC nomenclature that you have learned in 11th standard. If you have this present, then you can write the name for almost anything. Okay, almost anything. More than 95% of percentage of NCERT textbook questions, you can write it, except the benzene ones. Okay. For benzene, then I will give you some that is more easier, I would say. Benzene rings are more easier. Let me know if you're done with this. Yes or no, please tell me. Everyone done?
Yes,
No,
sir.
sir.
No, write it fast then.
Yeah.
Matthew, आपने किया है ना ये सब पहले? You were present in 11th
No,
standard,
sir, I
right?
was not there. Yeah, I was present in 11th standard, but then when you took this, I was not there.
अच्छा, बहुत लेट आए थे क्या?
Yeah.
Okay, okay. Mazia and Minashi, what about you guys?
Yes, I was there.
You were there, no? Okay, fine. Done?
Yes, sir.
Done. Okay. Now, note. And this note is very important because it's a very major misconception that the parent chain should be the longest chain. It should not be the longest chain. That is the least of our priority. This is something that you will find very weird, but please keep in your mind, or rather I should say, remove it from your mind. The parent chain, you don't have to look at the longest chain. Okay. Now, right, what would be the parent chain? The parent chain should be chosen such that it should contain functional group. It should contain functional group. That means, first of all, you have to identify the functional group. If any of those functional group are present, then that functional group should be present in the main chain. And no matter how long the other chains are, they are not our main chain. They are not our parent chain. Our parent chain is that chain which is containing the functional group. If not, if the functional group is not present, if not, then double bond. If not, then the double bond should be present in the parent chain. That means if you don't have any functional group, then you should fetch for a double bond. If there is any double bond, then that double bond should be there in the parent chain. If not, then triple bond. If not, then maximum number of substituent. And after that, even if you don't have any substituent also, even if you don't have functional group, double bond, triple bond, and you don't have substituent also, then the longest chain. So longest chain is our least of the priority. Most of the problem in IUPAC nomenclature, it happens only because the teacher, they say that you have to choose the longest chain. अरे बच्चे को पहले बता दिया longest chain. After that, they are saying that it should be containing functional group. Then they are saying it should be containing double bond. है ना? That is why it gets tough. IUPAC nomenclature is not tough if you choose the parent chain in such a manner that it contains functional group. If no functional group, then double bond. If no double bond is there, then look for triple bond. If there is no triple bond, then look for the parent chain that is containing the maximum number of substituent. Is everything done till here? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. So now I will take one example. Okay, so we'll name it in our way. Now I want Matthew, Saif, Hania, and Nawal. Please keep your mic on. The old student, you guys just wait here. Okay, you can answer if they can't answer. Okay, Matthew, Saif, Nawal, and Hania. Nawal and Hania. Functional group. Okay, so now you look at the list of functional group, all of you, and tell me, do we have any of these in the example here? Look in your copy for the functional group and tell me, do we have any of those functional group here? Do we have any of those?
No.
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 No. Hania, Nawal, no, na?
No.
No. Okay, very good. Now, after functional group, what do we see? Unsaturation. What do we see?
Unsaturation.
Unsaturation. Now you tell me, do we have a double bond or triple bond here?
Yes.
Yes.
Double bond.
Double bond. So what is the word for double bond?
En.
En.
En. Very good. Next. What is the parent? Now, in parent, wait a second. Okay, in parent, what we see that there are how many terminals? That means how many end carbons are there? Okay. So after this carbon, there is no other carbon, right? So this is one of the end carbons. This carbon, after this carbon, we don't have any other carbon. This carbon, after this carbon also, we don't have any other carbon. And after this carbon here, we don't have any other carbon. Yes or no? So we have three terminals,
Yes, sir.
A, B, and C. Is that right? Yes or no? Please tell me.
Yes,
Hania,
sir.
Nawal, समझ में आ रहा है? तीन
Yes.
terminal है? Okay, very good. Now you tell me, where should I start from? A, B, or C?
A.
A.
A. Why A? Because it is having a double bond. Correct hai? Yes or no?
Yes, sir.
Right? Okay, fine. So we start with A, and where should we go? Tell me. Oops, sorry. We start with A, and where should we go? Towards B or towards C?
C.
B.
C.
B may will not get maximum number of substituents, right? Yes or no?
C.
We have to look at substituents also, right? So you'll be getting maximum number of substituents if we go towards C. Okay, is this clear? Yes or no? Nawal,
Yes.
samajh mein aaya?
Yes.
Anya?
Yes, sir.
Yes, sir.
Yes. Okay, fine. So how many carbons have we chosen? We have chosen one. Now we are counting it. We are not numbering it. These are two very different things, numbering the carbons and counting the carbons. Counting you can do start from A also, you can start from C also. But when you are numbering the carbons, you have to start from any one of those. Okay, we'll also look where should we start the numbering from. Okay, so we will start counting 1, 2, 3, and 4 carbons. That means the parent will be bute. Is that right? Yes or no, please tell me.
Yes, sir.
Yes, sir.
Yes.
Bute. Oops. Bute. Okay. Now comes the substituent. Now what is substituent? Substituent is anything. What is substituent? Anything that remains after the identification of puff. What is puff? Parent, unsaturation, and functional group. Once we have identified the parent, unsaturation, and functional group, whatever remains is what it is. Substituent. So here there are two things that are remaining. The BR, we have not counted BR and we have not seen them, and the
And
CST is
methane.
remaining. Yeah. Now, then we will be doing substituent. So we have two substituents here. We have a bromo, and this is an alkyl which is having one carbon. That is why it will be methyl. Is this clear? Yes or no? Please tell me.
Yes.
Yes, sir.
Okay, now comes the main part, that is of numbering. Now we have two terminals here. We have the A terminal and we named it at C terminal. So where should I start the number from? Now numbering, it follows the same hierarchy as that of parent. So we choose the parent starting from functional group. That is why we start numbering from the terminal which is nearest to functional group. If not, then double bond. If not, then triple bond. If not, then the maximum number of substituent. Okay, then the nearest substituent you will count it. So now you tell me, where should I start the numbering from? A or C?
A.
A.
A, right? Everything is crystal clear? Yes or no? Please tell me.
Yes.
Yes,
Yes,
sir.
sir.
Okay. 1, 2, 3, and 4. So methyl is in the second carbon and Br is in the third carbon. Now, while writing the name,